So my name is Sunetra Gupta. I'm from the University of Oxford, and I'm going to tell you in 5 minutes about how mathematical models of pathogen evolution can be used to design vaccines, or really just explain my personal journey, which has led me from mathematical modeling to being a vaccinologist. So what I'm trying to do right now is develop a universal vaccine for influenza, and for those of you who have been wondering why you have to get a new flu vaccine every year, that's because the influenza virus is a master of disguise. It's able to change its outfit such that our immune system is no longer able to recognize it. What we mean, of course, by these particular garments here are parts of the virus that it presents to the immune system, which we recognize and then mount an immune response to, and it's through mutations in these parts of the virus that these sort of outfit changes are affected. The conventional wisdom about influenza is that it's in possession of a very large wardrobe, which would lead to the next question, which is that if influenza does indeed have this very large wardrobe and it mutates very rapidly, how is it that we even have an influenza vaccine at all? And the answer to that question is that in any one season, the entire population of viruses actually, it can't be right. It's going down, sorry. The entire population of viruses globally sports the same outfit. So within a season, you can be assured that there's only a single strain of influenza circulating, and the vaccine is made to correspond to that strain. And then, of course, that has to be updated when an outfit change occurs. Now, this actually poses a major evolutionary conundrum. If the wardrobe of influenza is this diverse and it's able to interrogate it regularly because it mutates so fast, how is it that an entire population of viruses will come out wearing exactly the same outfit? How is that possible? And this is a question that has exercised evolutionary biologists and epidemiologists for a long time, and various elegant solutions have been proposed to this problem. But about 15 years ago, we came up with a new solution which rather upended the idea that influenza has an unlimited wardrobe. So what we proposed instead, is that elements of the wardrobe were actually rather limited in their diversity. In other words, influenza may have 1 million hats, but actually it's only got 5 shirts, meaning that certain parts of what is presented to the immune system, which goes by the trade name of epitopes, are actually very limited in their conformations. And using a mathematical model, we were able to show that with that assumption, if you embed that assumption in the mathematical model, you can readily generate what we observe as the population dynamic of influenza, in which you have this enormous diversity reduction and each season is dominated by a single strain. So what that says is some elements of the wardrobe are limited in its diversity. Now, this has enormous implications for the development of a universal flu vaccine. What it means is that instead of updating the vaccine every year, if we're able to locate those elements where there's limited diversity and pack them all into a single syringe, you will get protection against all strains from a single shot. Now, of course, nobody believed us, which was actually quite good, and we've spent the last 10 years or so trying to see if this is actually true. And the good news that I have to report is that we have now found these elements of the wardrobes, the 5 shirts of influenza, using obviously a combination of laboratory studies and also further theoretical work, including AI techniques such as AlphaFold. We've now located the part of the wardrobe of influenza which is limited in its variability, and we've set up a company, Auto, whereby we are now exploring platforms on which we can hang these 5 shirts, pack them into one vaccine, which should protect us against all strains of influenza and also potentially against pandemic threats. Thank you very much for listening.